right, so let's start by going over this warm-up. We're pretty much doing exactly the same thing that we have been doing the last few, yesterday. Let's look at this example. It says you pay $22 to rent 6 video games. The store charges $4 for new games and $2 for old games. How many new games and old games did you rent? Does anybody know what our variables here are going to be? What do we say for our variables? What is 6? Any letters? Emma? So number of new games and number of old games. Do not forget to define your variables, please. We get this information by looking at the question. So whenever you're trying to define your variables, look at what the question's asking you. It says how many old games and how many new games did you rent? That's literally telling you what your variables should be. From here, I needed 2 equations. What were my 2 equations that I used? Jacob?
4x plus 2y equals 22, and x plus y equals 6.
Perfect. The first equation relates the cost of the games to how much you paid, and that second equation relates how many games you bought in total. Look about right? Now that our setup is done, this should just be a substitution problem like we were doing all day yesterday. So let's refresh our memories of what those steps were. I'm going to write them down real quickly. Number 1 is we isolate. We figure out one variable, get it by itself. Number 2, we substitute. I'm going to plug whatever I isolated into the other equation. Then I rinse and repeat. I solve. 4, I substitute again. And 5, I solve one final time. Those are our 5 steps. So let's do that here. I'm going to start by isolating one of these variables. The easiest variables to isolate are the ones that don't have numbers in the front of them. So I see x and y here, both don't have numbers in front of them. Therefore, it doesn't really matter which one of those 2 I'm going to choose to isolate, but I'm going to pick one. So let's do the... what did I do? I isolated the x value is what I did. So I'm going to take my x value and get it by itself. The way I'm going to do that is by subtracting y from both sides. Then I am left with x equals 6 minus y. Now that x is by itself on one side of the equal sign, I take everything else and I'm going to plug it back into my top equation, the one that I did not use. So that's step 2, substitute. That now looks like 4 times 6 minus y plus 2y equals 22. If you get to this step and you have more than one variable in your equation, so like an x and a y, you did something wrong. You should either only have y's or only have x's. That's how we know we did it right. So from here, now I'm going to go ahead and distribute. I'm solving for my remaining variable, which is a y. 24 minus 4y plus 2y equals 22. Combine your like terms. I'm doing a lot of solving here. There we go. Y equals 1. So there's all my solving steps. I'm good to go. Now I rinse and repeat. Now that I have one of my variables, I gotta plug it back in to get the other one. Now I can use either one of my original equations that I started with. These are the ones Jacob gave me to begin with. Or I always like to use the one that I simplified because it's already kind of solved. So I'm gonna take that y equals 1 and I'm gonna plug it in right here. So that leaves me with x equals 6 minus y, which is 1, or x equals 5. I can write that as a coordinate. Okay, it makes sense when I have x and y values that I can write them as a coordinate. Sometimes when we get into we're going to see in the next one, I'm going to use v's and b's instead. Doesn't make so much sense to write it as a coordinate, but we can always and should always write this in words. So this says I can buy 5 new games and 1 old game. Any questions on that? I'm going to do one more. I'm going to speed through this a little bit, but I want to do this one because it does pop up on your homework. So take a look at example 2. All 231 students in the math club went on a field trip. Some students rode in vans, which hold 7 students each, and some students rode in buses, which hold 25 students each. How many of each type of vehicle did they use if there were 15 total? So the first thing I do, as always, is I look at my question, and it's asking how many of each type of vehicle did they use. So my 2 variables should be relating to the number of vehicles. Let's call V the number of vans, and let's call B the number of buses. I need 2 equations. Can somebody help me write those 2 equations for this scenario? I'm looking for totals here. Do we see totals? How about a total for how many vehicles are they bringing total? It says in the question there are 15 total vehicles, so that means a combination of vans and buses makes 15 total vehicles. That's one equation. I need a second one. Jaden? Perfect. 25 students in a bus, 7 students in a van, equals a total of 231 students. Now I'm looking for what's going to be the easiest to isolate. V and B both don't have numbers in front of them, coefficients, so I can go with either one. I'm going to do the vans first. I'm going to isolate the vans, so that means I'm going to move B to the other side. So V equals 15 minus B. V is now isolated, so I'm going to take this and I'm going to plug it in right here for V. This now looks like 25B plus 7 times 15 minus B equals 231. Again, when I look at this step, I should make sure I don't have 2 different variables. I have B's and I have B's, and I'm good to go. So let's distribute. 25B plus, this is 105, minus 7B, equals 231. I forgot a 1 here, sorry. And I'm just going to simplify this. This is 18B equals 226, I think. Oh, sorry, not 226, 126. Divide everything by 18. B equals 7. Questions on that? Okay, so now that I have that, let's plug it back in up here to figure out how many vans. Vans is 15 minus 7, or vans is 8. So I brought 8 vans, 7 buses. Any questions on this? Okay, I wanted to make sure we saw these word problems a couple more times because I know that was the trickiest part of the homework, was creating those equations. So let's now flip over to the other page, and I'm going to show you some weird stuff. Okay, here's the weird stuff. So remember how yesterday we were talking about, we did this on the graphs 2 days ago. When we were graphing, there was when I had one solution, which is where my graphs crossed one time. Okay, that was all the stuff we did on these boards. We call that one solution right at the intersection. And our answer is like a coordinate, like x, y. But then we had two special cases, right? So all the stuff that we did yesterday for substitution looks like this first case. But now I'm going to introduce you to what the other options look like. Remember in a graph that those look like where the lines never touch because they are parallel, and we call that no solution. And then when the lines overlap each other, because they're the same exact line, remember we called that infinitely many solutions? So what I'm going to show you today is what does it look like without the graph when I have no solution or infinitely many solutions. So let's take a look at example 3. These are going to be mixed in there with all your other problems, so you're going to be starting these the exact same way that we always do. Take a look at example 3. First of all, what's the easiest variable here for me to isolate? What's going to be the least amount of work? The y. Do we see how this y is by itself? So I'm going to keep that y where it is. I'm going to move the 2x away from it. So to do that, I'm going to add 2x to both sides. Y equals 2x plus 8. Perfect. Step 1 done, as always. Now I'm going to take 2x plus 8. I'm going to plug it in to my other equation for y. Remember, when I'm plugging stuff in, I should only ever have one type of variable per problem. So I'm getting rid of the y. I'm replacing it with 2x plus 8. And again, I don't see anything fishy here, so I'm going to keep going. I'm going to keep solving like I always would because these are mixed in with our other problems. So this is negative 8x plus 8x plus 32 equals 12. Now what happens here? Now we see something's up. Right? We see something's up. We have a negative 8x and an 8x. When we combine like terms here, what happens to those? Read. They cancel out to be 0. So what I'm left with is 32 equals 12. Now, I already told you that I have two weird cases, right? No solution and infinitely many. What do we think this one would be? Why is it no solution? Yeah. So anytime we have a false statement, well, first of all, our x's have to cancel out. We can't have any x's left. But if I'm left with a false statement, I don't just write false, I write no solution. Does that make sense? Questions on that? All right, let's try example 4. Same thing. What's going to be the easiest variable for me to isolate here? X. X is already by itself. I just got to move that 4 to the other side. So let's subtract 4 from both sides to get x equals 3y minus 4. I'm going to take 3y minus 4. I'm going to plug it in over there for x. So this is 2 times 3y minus 4 minus 6y equals negative 8. I don't see anything wrong with this right now, so I'm going to just start distributing. 6y minus 8 minus 6y equals negative 8. Again, I'm seeing my y's cancel themselves out because when I combine like terms, I get 0. What I'm left with is negative 8 equals negative 8. Is this a true or false statement? It's true. Negative 8 does equal negative 8. I have to have the variables cancel out first, but then if I get a true statement, I'm not just writing true, I'm writing infinitely many solutions. And I know infinitely is a hard word to spell, but I will make fun of you if you spell it wrong. Just between us. Any questions? Okay, I'm going to show you one more weird one, and then we'll be done. All right. I like looking at problems like example 5 because I think it just feels weird when we solve it and we get a little bit nervous. Is there something already isolated in 5? The y's are both isolated in both equations. So it doesn't really matter which one I put where. I'm going to start with taking the first equation, and I'm going to take this half of my equation and plug it in for y here. And it feels weird just because there's nothing else on that side of the equation. So it's like, oh, am I doing this right? But just trust that you are. I'm left with, on the other side of my equal sign, oh, I don't want green. On the other side of my equal sign, negative 2x minus 1. So it just kind of like feels weird. But now I'm just solving for x. All that's left is x's. I'm going to solve this like I do any equation with two variables, one on either side. And I'm going to move my x's to one side. I like to deal with only positive numbers, but it doesn't really matter which side, left or right, you put it on. I'm going to move all my x's to the right side. So plus 5x on each side is 3x minus 1. Do a little bit extra solving here to get negative 16 over 3 equals x. Is that okay? Can I have a negative 16 over 3? Are we fine with that? It's fine. We're not going to panic. I know that now that I've introduced you to the idea of having no solution and infinitely many solutions, that we see crazy fractions like this and we start to freak out a little bit, but I need you to understand that a fraction is a solution, and if you got 0, like x equals 0, y equals 0, that's also a solution that can happen. We're not going to freak out when we see weird stuff like that. Now from here, I solve it exactly the same. I'm going to take that x value, I'm going to plug it in. It doesn't really matter which original equation I plug it into. I'm going to go with this one. Y equals negative 2. My x value is negative 16 over 3 minus 1. Do a little bit of fraction multiplication. I know it's scary, but this is 32 over 3. Minus 1, instead of minus 1, I'm going to change that to 3 over 3. That's the same thing as 1. And then y equals 29 thirds, which is okay. I'm going to write my answer as a coordinate, just like I always do. Is that okay? Are you okay with that? Fantastic.